Number 19 from section 15.7 is to take the region bounded by these two surfaces and set up a triple integral 6 different ways. So first of all, this is this surface is a paraboloid opening parallel to the y-axis, or opening around the y-axis, centered on the y-axis, whatever you want to say. It's both opening downward in the x direction and the z direction. So it's, if this is the positive y-axis here, this is positive x, this is positive z. In the x direction here, it's headed down this way. It intercepts the x-axis at -2 and +2. Likewise, in the z direction, as a parabola going this way, it's the steeper one. It intersects here at 1 and at -1. So this is 4 right there. I'm cutting it off at y equals 0, so that's the xz plane. In the xz plane, it looks like an ellipse. If I plug in y equals 0 here, in fact, I have that right here. If you plug in y equals 0, move the x squared and the 4z squared over, you got this equation right there. Other traces of interest here in the xy plane, that is, let's set z equal to 0. The equation looks like this. Right? And in the yz plane, that is with x is equal to 0, you're looking at that parabola. Okay. I'm going to use all that information as we go here, but I want to do this 6 different ways in less than 15 minutes, and I've already used up a minute and a half. So here we go. First of all, I'm going to set this up as a triple integral dz, dy, dx. This is, I think, the most intuitive way that people have, because each variable, inside variables can be functions of outside variables, but the outside one has to be a constant. So z can be a function of x and y can be a function of x, but I need x to be constant. So here I go. I'm going to work my way in, starting from the outside. So if I'm doing z on the inside, I'm essentially looking at what does this project down to onto the xy plane. Well, both projects up and down. But in the xy plane, the minimum x is -2. The maximum x is +2. For each value of x in between, y is running from 0 out to whatever this parabola is. Well, that's in the xy plane. That's this right here. So y goes from 0 out to 4 minus x squared. Then, for each value of y on that line, you're going to say, what does z do? Well, z goes from some bottom part of that up to some top part. It's hard to see where it actually hits bottom and top, but whatever the surface is, that's where it hits, the paraboloid. Well, how do I solve for z there? Well, I got to go back to this equation and say, solve for z. Well, solving for z, I've got that z is equal to, so if I bring this over, bring that over. So I've got 4 minus x squared minus y, and then divide by 4, and then take the square root of that, plus or minus. So on the bottom side, this is minus the square root of 4 minus x squared minus y over 4, and on the top side, it's plus the square root of 4 minus x squared minus y over 4. Okay. Now, let's change the order. Let's do this still with the x on the, still with z on the inside, but do it dx, dy now. So now I've got to look at y first and say, what's the minimum y value? What's the maximum y value? Well, the minimum y value in that xy plane is 0. The maximum y value is 4. For each value of y in between, what does x do? Well, for each value of y in between now, oops, I want this to be red. For each value of y in between, x is going this way from that side to this side. Well, in the xy plane, I'm looking at this thing, so if I solve for x, 4 minus y square root, alright, in that xy plane, the minimum x is minus the square root of 4 minus y, and the maximum x is plus the square root of 4 minus y. Then, for each value of x along that line, you say, what is z doing? Well, it's doing the same thing it was before, and so the inside limits of integration are the same as they were before. And the question marks don't indicate that I don't know what they are. The question marks are just that I don't feel like writing this down again, right? But these limits are the same as those limits. Okay. Now let's do, how much time? Oh, 5 minutes. We got 10 minutes to go. Good. Let's redraw this region here real quick. So it's kind of an ellipse in the XZ plane. It's got a parabola going this way. It's got a parabola going down that way. Yeah. So now we're going to set up this integral. Let's put the y on the inside and the z and the x on the outside. So with x on the outside, the minimum, okay, two things. Focusing on dy in the middle. So I'm going to look at the xz plane. Essentially, I'm projecting everything over onto the xz plane. So what's the minimum x and the maximum x, which is minus 2 to 2. Then for each value of x in between, what does z do? Well, z goes from something down there to something up there. Well, in the xy plane, remember, that was with y equals 0. We're looking at the ellipse x squared plus 4z squared equals 4. So solving for z is equal to 4 minus x squared over 4, square root of that, plus or minus. So z goes from minus the square root of 4 minus x squared over 4 to plus the square root of 4 minus x squared over 4. And then for each value of z along that line segment, you say, what the heck does y do? Well, y starts at 0 and it goes out to whatever you're at when you're on that paraboloid. And so 0 to, and y was equal to, the original equation of that paraboloid was 4 minus x squared minus 4z squared. Okay. So y is a function of both x and z on the limits here. I have z just as a function of x on my limits, and then I have x just as constants. Okay. Now setting it up similarly, whoops, let's do this in blue. With y in the middle, then x, and then z. Z on the outside, I need the minimum z, maximum z. That's from minus 1 to 1. For each value of z, I then need to say, what does x do? So for each value of z, I'm looking at x running from this side to that side. So that's this equation again, but solve for x. So x is equal to 4 minus 4z squared. Take the square root of that. So I'm going from minus the square root of 4 minus 4z squared to plus the square root of 4 minus 4z squared. Right? And then for each value of x along that thing, you say, what does y do? Well, y is doing the same thing it did before. So this is from 0 to 4 minus x squared minus 4z squared. Okay. So we've had z on the inside, we've had x on the inside, sorry, y on the inside, now we have to do x on the inside. So here we go. We're going to draw this picture one more time, if I can. So I've got this ellipse going this way in that direction, and a parabola going this way, and a parabola going down, if that's ugly. This time I'm going to focus on x on the inside, and then dy dz or dz dy. Let's do dz dy first. The thing is, with x on the inside, I'm kind of focusing on the yz plane on the outside. So there's this parabola in the yz plane, which was y equals 4 minus 4z squared. Okay. So what's the minimum y? What's the maximum y? Because I got y on the outside. Minimum y is 0. Maximum y is 4. For each value of y in between 0 and 4, what does z do? Well, it goes from the bottom of that parabola to the top of that parabola. Well, that's solve this thing for z. So z is the square root of 4 minus y divided by 4, plus or minus. So it goes from minus the square root of 4 minus y divided by 4 to plus the square root of 4 minus y divided by 4. And then we say for each value of z along that line segment, what does x do? Well, x runs from some back of the paraboloid to some front of the paraboloid. And so I got to go back and look at the equation of the paraboloid, which was y equals 4 minus x squared minus 4z squared, and solve that for x. So solving that for x, I find that x is equal to minus the square root of 4 minus y minus 4z squared on the back side, and on the front side it's equal to just the positive square root of 4 minus y minus 4z squared. I got one more to go. Do I have time? Oh, I do. I got 3.5 minutes left. Here we go. So, this time we're setting it up still with the x in the middle, and then dy, and then dz. So z on the outside. What's the minimum z? What's the maximum z? Minus 1 to 1. For each value of z in between, what does y do? Well, y goes from 0 out to that parabola, out to that parabola, right? You're on the x, y, you're in the yz plane. This is x, this is y, this is z. And so 0 out to this thing, 4 minus 4z squared. And then for each value of y on that thing, so you've picked a value of z, you've picked a value of y, and you say, what does x do? Well, x is doing the same thing it did up there, so I've got those same square roots again. I've got minus the square root of 4 minus y minus 4z squared to plus the square root of 4 minus y minus 4z squared. Any one of those integrals, or those iterated integrals, will tell you the triple integral of f over that region. And depending on what f is, you may want to do one order or another, but you have the option of all 6.